Hey, good morning, everyone. Here we are, lesson one, distance learning. This is pretty lame. We're gonna make the best of it, okay? All right, so I'm gonna push these out daily, and we're just gonna be open with each other. We'll keep chatting about how they're going, whether they're super boring. Can try to mix it up, but we'll just jump in here, and you guys should have a copy of this. Hopefully, you can print it out. If not, you can just take notes as you go, or you can just watch it. Okay, so what we're going to do is we're going to start in calculus talking about this idea of a limit. Okay, and you guys are used to functions, and you've seen this function notation many times before, but now all of a sudden there's this LIM in front of it, which stands for limit. And then if you look a little closer, you've got this x with an arrow to c. And this is just saying, look, let's look at a function and let's get close to an x value of something. Normally this will be a number, but in this case it's c. And then where is the function, right? So again, as I get close to c on this function, where am I? Okay, and there's a couple pictures here. And this one here is a good place to start. Okay, and so what's happening is we've got our C value that we're going to approach. And the limit process is saying, look, as I squeeze in this way and I squeeze in that way, right? If I'm on this roller coaster and I'm coming back towards this X value C, or I'm coming this way towards an X value C, where am I, right? That's where I'm at. Okay, so this limit process is different than actually finding a function value. Okay, so I'm going to do a little sidebar here, looking at this function here, 2x plus 5. So long ago, right? Algebra 1, you guys are probably in middle school. You got y equals 2x plus 5, and you know everything about it, right? And then you go up in mathematics and you end up dealing with function notation, which just tells you that this thing passes a vertical line test. And I could say, well, what is the function value at 2, right? Well, the function value at 2, you simply would plug in. You get 2 times 2 plus 5, which is going to be 9. And you know that graphically what that means is that when I'm at an x value of 2, right, I'm up here at a function value or a y value of 9. Okay, this is inherently different than the question, what's the limit as I get close to 2 of this function, 2x plus 5, right? And this is your answer, right? And so for limits, what we're doing is we're trying to find out where we're at, okay? And we don't care about what happens at 2, right? We know that at 2 it's 9. What we care about is as we get really, really ridiculously close to 2. Well, what does that mean? We'll put 2 on a number line, and you're slamming in this way. You're at like 1.9 and then 999, and you're coming this way and you're at 2.001. And so we can look at that by using our calculator. And if you've ever done this before, right, you go into your function, you put in that value, and then what we want to do is we want to get into our table of values over here. Okay, so if I hit second graph, it gives me particular values. And we're looking at getting close to an x value of 2. We know that it's 9. That's not what we're interested in, though. We're interested in getting ridiculously close to 2 from both sides, right? And then analyzing where we're at. And so how can I switch that? Well, right up here is table set. So if you guys go second, window, let's start our table. We want to get close to 2. Well, what's close to 2? 1.9 is pretty close to 2. But then here, this delta table, I don't want to go up by 1 or my next value is going to be 2.9, right? So let's go up by like 0.01. Okay, those are going to be our steps. So now if I go back into my table, okay, you can see that at 1.9, I'm at 8.8. And then 1.91 and so forth. I'm getting ridiculously close. You can see the pattern here. It looks like I'm approaching a value of 9. And this is coming from the left-hand side. What about from the right? Well, coming in from the right, I'm at x values bigger than 2. As I drop back down here, these are decreasing and getting closer and closer and closer to 9. So using a table of values, okay, back on our notes, we found that the limit as x approaches 2 of that function 2x plus 5 looks like it's going to be 9. Okay, and I can't say this enough, and you guys will get sick of me saying it, but the limit process does not care about what happens at 2. Look at this graph in the middle here. Okay, there's a way to create a function where the limit, as I'm coming in towards c from the right, I'm right here, and then coming in from the left, I'm right here. Okay, and you can see that there's a hole there, but the limit process doesn't care. Even though the function is defined up here, this limit would still be equal to L, even if the function is not defined there. Okay. And so let's jump down here to example 2 and see what happens. So let's investigate the limit. This is called a piecewise function. Nobody ever likes piecewise functions. I get it. It's just pieces, right? Literally in your guys' brain, this stands for y. Y equals x should not intimidate you. That's a straight line with a slope of 1 and a y-intercept of 0. This other piece is y equals 1. Y equals 1 is a horizontal line. Okay, so it's literally taking this value, y equals x, and it's taking this function, y equals 1, and it is piecing them together, right? And it's piecing them together in this manner, saying, look, if you're to the left of 0, you need to be on this line, which would be this part, right? Because I'm left of 0. And then if you're bigger than 0, you need to be on this line, which is that. And so graphically, if you're going to analyze this piecewise function, this domain thing here is an issue because we can't be at 0. So we can't be there, right? And then I should be on that line to the left, and I should be at the horizontal line 1, but not there at 0 to the right. Okay? And so this is a piecewise function. You guys will get better at this. Just consider the individual pieces and then check your domain constraints. Okay? And they want us to know what is the limit, okay, as x approaches 0 of that function. Well, the only way to do that, you guys, is to analyze it coming from the left and the right. Okay? I always do this with my students with the fingers. When you guys are doing the limit process, if your fingers are not touching, the limit does not exist. Okay? And so I'm going to introduce some new notation here. I want to think about what's the limit as I get close to 0 from the left. That's what that little negative sign means. Okay? So what you're supposed to do is jump on your function and get close to an x value of 0 from the left. So I'm coming this way, and it seems like I'm approaching a function value of 0. Okay? Similarly, let's do limit as x gets close to 0 from the right-hand side. Well, coming in hot from the right, I'm over here at 1 and 2, and I'm coming in towards 0, I'm coming in towards 0. Where am I as far as a y value is concerned? That's what this is saying, right? As x gets close to 0, what's happening to the function? Well, the function is right up here at 1. Okay? And since these are not equal, the overall limit as you get close to 0 of this function does not exist. Okay? Now, that's different than up here. Let's look at the graph here. We know this guy here starts at 5 and has a slope of positive 2. There it is, y equals 2x plus 5. And as I get close to 2, okay, think about your fingers here. You're coming in this way and you're coming in this way. Your fingers are definitely in the same exact place. And where are your fingers? They're at 9. And that's why the limit existed in this one. Okay. And then we just kind of put this together, right? It's this fancy theorem. And it just says, look, the overall, I'm going to call this overall, the overall limit exists. This is an if and only if statement. Okay, that's a two-directional logic statement. The limit exists if and only if the limit from the left, so this we call left-handed limit. And here we got the right-handed limit. Okay, if and only if the left and the right hand limits are exactly the same, right? Your fingers are in the same place. You're at a value of 9 from the right, at a value of 9 from the left, so we're good to go. This is bad, right? The left hand limit did not equal the right hand limit, therefore the overall limit does not exist. Okay, so basically, guys, in AP Calc, right, we're going to go through some limits. We're going to evaluate them, and where does this show up on the AP exam? It's going to be multiple choice style questions. There'll be 2 or 3 different multiple choice questions usually, and it's just a game, right? There's 45 multiple choice questions. I'll say this all the time: you got to get in the 20s to be in the game to pass. It's super easy. We got all year to figure out 25 multiple choice problems you guys can get right. All right, keep it real.